Yes, perfect.
Okay, great. Today I'm going to be talking about an approach to designing gestures for natural user interfaces. My name is Shannon Bailey. I'm a human factors scientist at Emmertech, which is a startup company in Florida that works on making virtual reality trainers for surgeons. And this work was done in collaboration with Dr. Cheryl Johnson of the U.S. Navy. And this is an approach to designing natural user interfaces that were gesture-based. So just a quick overview of what I'll be discussing in this current presentation. I'm first going to give an introduction of what natural user interfaces are, because they are fairly new in terms of technology, where they fit in with the context of other human-computer interfaces, what makes a natural gesture actually feel and be interpreted as natural, and then the development challenges around developing natural user interfaces. And that will lead into the studies that I'm going to present the results of here today. We performed 2 different studies in this approach to designing natural gestures. The first was to define what the natural gestures are, and then to have another group of participants to interpret the gestures to see if they were interpreted as, in fact, natural. And then I'll conclude with some recommendations for how to go about designing gesture-based interactions for your own natural user interfaces. So first, just a quick introduction of what natural user interfaces are. Natural user interfaces, or I'm going to refer to them as NUIs in this presentation, are interactions with a computer system that use the body to directly interact with the computer, as opposed to a proximal device that then interacts with a distal cursor on your screen. So a device that you might be used to using is a keyboard and mouse or a joystick or a controller to interact with computer or gaming systems. But these are interfaces between the human user and the computer system. In contrast to that, natural user interfaces use the body to directly interact with the system. And some common examples of natural user interfaces include voice commands, eye tracking, so potentially using your gaze where you're looking to determine interactions, and then gesture input. And I'm going to be focusing mostly on gesture-based interactions during this presentation. So why now? Why do we care about natural user interfaces at this point in time? There have been some technological advancements that have happened recently over the past decade, especially, that have made natural user interfaces possible at this point in time, whereas they would have been too expensive or the technology just wasn't advanced enough to be implemented to a high degree of accuracy. So things such as voice recognition and motion tracking have both gotten much better just in the past 5 years, that now these systems are at an accuracy level that they can be implemented into a variety of computer systems and used to interact in a more natural way with the computer. And who cares about natural user interfaces? So natural user interfaces have been used already previously in gaming systems, such as if you think about like the Microsoft Kinect was used previously, Wii games where you would motion and that would interact with the game. Other systems have also used natural user interfaces, and they're becoming more and more prevalent. So education designers, people who are working in the training industry, they already are looking to natural user interfaces to make these systems easier to use for people, and then also make those learning outcomes better. So for example, one of the education systems that I developed a prototype for that used a natural user interface was a system that taught the concepts of optics. So how lenses and mirrors reflect and refract light. People would move objects as lenses and mirrors into a beam of light on this computer screen, and then use gestures to interact with that system in order to understand the concepts of optics. Additionally, when I was working with Dr. Johnson at the Navy, we worked on a trainer that was a procedural trainer for a maintenance procedure in virtual reality. And with the virtual reality headset on, users would use gestures to interact with the trainer in order to learn the procedure for this maintenance task. So people who care about natural user interfaces, education, gaming, training, but also it's another way to expand the accessibility of computer systems to a wider, more diverse audience. And Accessibility, not every gesture is going to be accessible for every user. So some gestures, if people who only have one arm are not necessarily going to be able to use two armed gestures. But if the more types of interactions that you can implement into a system, the more accessible that system will be for a variety of users. So having gesture commands in addition to voice commands or other types of interfaces will just increase the accessibility. So that's where natural user interfaces are, just a general background of them, but where do they fit in with human-computer interfaces today? So computer interfaces have changed a lot, but we're kind of stuck in the same graphical user interface that has been around for the past 30 years or so. So in the beginning, computer interfaces were often command line interfaces where you'd have to literally type in a command on a keyboard in order to make any interaction happen. That was around the 1960s and 70s and 80s. And then in the 90s, we transitioned to graphical user interfaces, which were much more user-friendly. And these graphical user interfaces are typically defined by what you recognize in a computer system today: windows, icons, menus, and pointers. So this is considered the WIMP model, W-I-M-P. And most computer interactions that you have today, you'll recognize using windows, icons, menus, and pointers. However, this WIMP model has limitations. And I don't normally read quotes straight directly, but I thought that this quote was a really excellent depiction of what the issues are with graphical user interfaces. And this quote is from Andy Van Dam, who is a pioneer of computer graphics. He helped to develop some of the very first graphical user interfaces. And he said that, however user-friendly, an interface is still an intermediary between the user's intent and the execution of that intent. As such, it should be considered at best a necessary evil because no matter how fluid, it still imposes a layer of cognitive processing between the user and the computer's execution of the user's intent. The ideal interface is no interface. So Andy Van Dam said this in 1997. So over 20 years ago, he was saying that any interface that we have, a graphical user interface or command line interface, these interfaces impose an extra level of mental processing on the user. And ideally, we'd have no interface. So he's suggesting a natural user interface here. But then the big question is, well, what makes an interface natural? So for gesture-based natural user interfaces, we use the concept of natural mapping. So how closely a control matches the intended action. So natural mapping, as explained by Don Norman, it basically is looking at how much does what you want to do, how closely is it that you are, the command interacts with that intent. And this has been described in different ways, but the way that I like to think of it as is on this continuum of naturalness. So this continuum of naturalness, which was a concept proposed by Stewart, basically plots gesture and other interactions on a scale from very arbitrary to very natural. So something that you might not think of as being an arbitrary interaction, because we've gotten used to it, is just double clicking a mouse. So double clicking a mouse doesn't have a map that correlate between what you're trying to do and then the actual interaction on the computer. So double clicking, like it's not like you're reaching out and grabbing an object. That would be more of a natural interaction. If you're reaching out to grab an object on the screen, double clicking has no inherent meaning behind it. You're not reaching out to touch something, you're not moving it, you're not manipulating it in any way, you're just double clicking. So that's an example of an arbitrary interaction that we've just learned over time, and so now we hardly think about it. But what does that mean for gesture-based interactions? Can you also get used to a gesture-based interaction that starts out as arbitrary? The evidence so far is probably not. So there's not yet a standard vocabulary of gesture-based interactions, and this actually has caused some issues because different gesture-based systems, such as like the Microsoft Kinect and which is now an older, way older version, they had a different type of gestures than the HoloLens that is out now, and the HoloLens has different type of gestures than the Oculus Quest that's out. So there's not a standard type of gesture that is used across systems yet, and that is because we're in the very early stages still, maybe middle stages of doing gesture-based research to find out the degree to which different gestures are usable from a human perspective, and then also whether or not these usable gestures are even interpreted as natural. Because the more natural an interface, theoretically, the easier it is to mentally process for the user. So examples of arbitrary gestures that have been used in NUI interfaces, or natural user interfaces, are this lasso is the picture on the far left is an arbitrary gesture that was part of the Microsoft Connect, and you made two fingers and then did a little loop there, and that was a select gesture. So that was hard for users to remember, and also sometimes hard for them to perform, but it was easy for the computer to recognize. Whereas an example of a natural gesture interaction would be making a pinching gesture to select something small, or making a grabbing gesture to select something large. That has an inherent meaning behind it, and it's easier for the user to remember. But there are development challenges when you're making natural user interfaces that have limited the development so far of these different gesture-based commands. Mostly technological limitations. So the resolution, latency, and recognition, while they have gotten better, there have been limitations that have greatly impacted how gestures have currently been developed. So the resolution, whether or not a computer can recognize a small, minute finger gesture versus a very big whole body gesture, is the resolution. The latency, if a system doesn't have the refresh rate to pick up on, if there's a latency delay between the action and the computer recognizing it, then you're not going to be able to have dynamic gestures that involve moving or mimicking an action. You're going to have to rely on static gestures if you have a lot of latency. And then finally, just recognition. The computer recognition is a key part of being able to have this human-computer interface. If the computer can't recognize the gesture that the human is doing, then you're not getting this, this command. It's not an interaction at all. So a lot of previous systems have used a computer-centered approach in order to develop gestures. So the gestures that were developed were easier for a computer to recognize, but they weren't necessarily developed initially with the intent that they're easy for the human user to recognize or to perform. And this imposed a layer of mental processing, extra mental effort on performing the gesture. So if the user couldn't remember the gesture to select, it causes frustration and strain in not being able to recall the gestures. So all of this leads to the design of the current approach that we use for designing natural user interfaces. The questions that we came at it with how to design these natural gestures were, first, what gestures are even considered natural for an intended action? From a user's perspective, not starting from the computer's perspective, but starting from the user's perspective, what do they think of as natural? And then the second question was, if a group of users thinks that these gestures are natural, would other people interpret those as natural? So for example, if a gesture is natural for me, is that necessarily going to be a gesture that is recognized as natural for other people? It's hard to develop a gesture-based vocabulary or system if people have different interpretations of natural gestures. So those were the two questions that led to the two studies that I'm going to describe now. The first study was to define what gestures are natural. So we first brought in 17 participants, and they performed in a random order the actions that you see on that list there, the 9 common computer actions that we came up with. These are common object manipulations you would need to do with a computer interface. Enlarging or shrinking an object, moving it, rotating it clockwise or counterclockwise. So participants came into the lab and they performed these gestures in a random order in front of a Microsoft Connect version 1, just to see if they could even be recognized by the computer interface. And then these gestures were then coded on their characteristics of natural gestures coding scheme that was developed previously by other researchers. And 2 independent coders rated the participants' gestures. And they actually had 100% agreement based on the characteristics of natural gestures coding scheme, which just goes to show it really emphasizes how similar the gestures were between each other, or between the participants, because the gestures had a lot of the same characteristics for the same action. All the gestures were dynamic for every action by every participant. So they weren't doing a static gesture, they were moving to conduct these object manipulations. All the gestures were pantomimed, so they were mimicking the actual interaction with a real world object. They weren't using some sort of arbitrary mechanism to perform that action, except for the select gesture. So a lot of people for the select gesture, some of them would grab, but a lot of them would also point as a select gesture. So pointing, that could be considered not pantomiming the interaction. And most gestures were also one-handed. This is just an interesting side note. Most gestures were performed with only one hand, except for the shrink and enlarge gestures. Those were typically done with two hands. So we, based on the coding scheme, narrowed down the top gestures that were considered natural for each interaction, and it was overwhelmingly one or two gestures were performed for each action. There was not a lot of variability here, so we didn't have to analyze a bunch of different interactions because the variability was so low. There were usually only one or two interactions per action that were even performed. And I would show you videos of these, but the video would be a difficult thing to get videos into this presentation. So, so then the next part of the study was looking at, we have these gestures that people said these are natural gestures for these 9 actions, and we wanted to look at how do people interpret those gestures. So we looked at a separate group of participants. We had 169 participants, looked at 26 different gesture videos. So we had the 18 gestures that were from the first study that were considered natural for different interactions. And we also included another set of gestures that were considered arbitrary. These came from different SDKs, software development kits for different gesture-based systems. So some of them were gestures from different technologies that are already out there. We used those gestures, and those were considered arbitrary because they weren't attached to a certain action. And then we had participants to watch those gestures videos that were 3 to 5 seconds each. And then for each, they would look at an action gesture pair and rate on a 6-point Likert scale between natural and arbitrary how they thought that that gesture was for that action. So do you think that moving your hand up, is that a natural interaction for moving an object up? For rotating an object, is rotating your hand, is that a natural interaction for rotating an object? Those were the ratings for this study. This is just a list of the arbitrary actions that we included. Some of them were from SDKs, and some of them were from previous studies that had been done. And I can go more in detail on those if you have questions. And the results of this study, the second study, confirmed that the gestures that were performed in the first study were in fact rated as natural by a separate group of participants. And I won't go through the whole graph here, but basically what you can take from this graph is the top 2 videos for each interaction that you see there. Those were always rated as most natural, and they were both from the first study. So all of the gestures that were intended to be natural from the first study were rated as significantly more natural for each of the interactions. And a lot of them were not even close. The runner-ups, these are just the top 5 videos that were rated as most natural for every interaction. And the top 2 were overwhelmingly the gestures that were performed from the very first study. Okay. And so, and this is just a depiction of the gestures that were rated as most natural for each of the 9 interactions. So you can see that it makes sense. The moving an object up, people move their hand up, moving an object down, down, left, right, clockwise, counterclockwise. Enlarging, use 2 hands to moving outwards to enlarge, and shrink, 2 hands coming in. So these were gestures that were created in the first study by a group of participants and then rated as most natural by a separate group of participants in the second study. The only thing that was different, the only one that was in between, kind of on the line as to which one would be the most natural gesture, was the select gesture. Most people in the first study pointed forward, and then people rated that as most natural, but a close second for that one was a grasping gesture that was done in the first study, and then people also rated the grasping gesture as natural for the selecting interaction. But for this, it just barely won out with the pointing gesture. So to conclude what we did here, we looked at a two-step approach to defining what are natural gestures for a new natural user interface. And we did that by having a group of users actually define the gestures. And then to confirm that those gestures were interpreted as natural, we had a separate group of participants to rate those gestures on a scale from arbitrary to natural. And they were overwhelmingly rated as natural by a separate group of participants. The gestures also overwhelmingly mimic direct manipulation with an object, so they were pantomiming the action. And we also confirmed that, at least with an older version of a motion tracker, the Microsoft Kinect, which is nowhere near the best kind of motion tracker that's out there today, it's obsolete by today's standards. Even this early version of a motion tracker was able to recognize the gestures that were performed by these users. So that helped with some of the development challenges that we were considering, which is, can a computer recognize what a human might perform? And in our study, the answer was yes. And the limitations of this current round of studies were that these participants were predominantly right-handed, but there were no differences when we were looking at the rating scale between the left and the right-handed participants, so we just collapsed those ratings. Another issue is that systems do change pretty rapidly. What was available, what just came out this year for the Oculus Quest, which is a VR headset, those gestures were just in beta form just a few months ago. And those gestures differ from what is available from other systems like the HoloLens. And also gestures might be culturally specific. So this study was performed in the United States with a college sample, and it could be that different gestures are natural for different users in different cultures, and that's something that is a limitation that we would like to study further.